Buonasera a tutti, sono Paolo Ravazzani, sono il direttore dell'Istituto di Elettronica e di Ingegneria dell'Informazione e delle Telecomunicazioni del Consiglio Nazionale di Ricerche. Stasera sono veramente particolarmente felice di dare il benvenuto al professor Bruno Siciliano, che ci verrà a raccontare cose estremamente belle sulla robotica, e ringrazio per il tempo che ci sta dedicando per i nostri giovedì dell'Istituto. Chiudo qui semplicemente ricordando a tutti che l'evento viene registrato e verrà pubblicato sul sito web dell'Istituto. Detto questo, come ci siamo accordati prima, passo all'inglese e quindi I will ask Bruno Siciliano to start his talk, and Bruno, the floor is yours.
Thank you very much, Paolo, and warm welcome to all those connected. I think I'm on a different channel. I don't see the people connected, but I hope that now you see my screen, which I'm sharing. And also we tested the sound and it should work as well. So this is a special occasion, and it's you know, I'm really proud and flattered to give this talk at your institute, and also this is a special year for National Research Council because it's a centennial. So you know, I hope that this talk is at the same level of the talks that you have been attending so far. I've been working in robotics for most of my life, since I was a PhD student. And actually, I've found memories, since this is a CNR event, National Research Council event, I've found memories of the Progetto Finalizzato Robotica, which is like finalized projects in robotics, which dates back to 1989 and 1994, in which you know, there was a big boost of robotics activities in Italy. And this was the sort of beginning of a successful story for the robotics community in Italy. And I have to say that now we have a new project on medical rehabilitation in robotics. Paolo is the coordinator of the project. So I mean, the legacy to CNR. When we speak about CNR robotics, there is a strong legacy in our community. I decided to. I mean, I could have talked about many topics in robotics, but since this is going to be a sort of talk with a general interest by the audience, I decided to speak about the status quo of robotics and AI, and just to discuss about how new technologies like 5G can be proactive for the further advancement of the field. So I will start with just showing, to get into the mood of robotics. I'm going to show you a 5-minute video clip which I edited, which includes the fanciest and you know, most extraordinary robots which have been developed in the various labs around the world. So I just let's see if okay, yes. So you saw robots in action, and let's see what is the science underlying the many applications that I show in the video clip. This is the science of robotics, and as you notice, I'm saying science, whereas you would think that robotics is basically engineering, it's mechatronics, it's technology, but actually robotics is a very transdisciplinary field which goes across the boundaries of engineering and technology. And I will come back to this concept, in one of the final slides. So robotics, according to the definition, which is commonly accepted in our community, robotics is defined as the intelligent connection of perception to action, which is the same feedback principle of humans, because the dream of robotics is to make intelligent machines to emulate the performance of the humans. So you have three main systems into any robotic system, namely the sensors, which provide all kinds of perception. In the vignette, you see, for instance, the use of both visual and haptic data. Say that I'm thirsty and I want to get a glass of water, I have to localize the glass, and then I have to grasp and just grasp the glass and drink the water. So that's perception. Then the sensory data are used by brain, by the intelligence, by the control, which sends some sort of commands, and the commands have to be implemented. So into a robotic system, be sure that you will also find what they are called some actuators. You can think about motors, like servo motors. So the actuators are those mechanical systems, actually electromechanical system, or maybe hydraulic systems or pneumatic systems, which implement the action which is commanded by the control. So this is robotics. Now, what about AI? Now, of course, we can give more precise definitions of AI. But in a very broad sense, just the goal of AI is to use computers to mimic the functions and the logics of the human mind. I hope that everyone agrees with this definition. So in AI, of course, it's tautological. We find intelligence, which is the same intelligence as in the definition of robotics. But of course, we also find perception, because think about maybe, I don't know, like ChatGPT or Alexa. Just like typically, just any kind of AI algorithm allows interaction with humans by using some perception data. Now, this is one such example of contamination, of cultural contamination across two different fields, the field of AI and the field of neurosciences. There's a study which is quite well known in the literature, and this is by the neuroscientists, and this is the so-called cortical homunculus. What is the cortical homunculus? It's a sort of a parasitic view of an homunculus whose sensor organs are proportional to the importance of sensing for the human. So as you see, you would probably expect that vision is our most important sense. But as a matter of fact, this homunculus has two such big hands. So perhaps like the tactile perception is even more important than the visual perception. And you see that for the visually impaired people, like blind people, they have a normal life because they can interact. They can interact with the world just by exploring, by touching, and they can reconstruct a map of the environment without seeing, through the exploration, through the touch. So we have intelligence and we have perception. Now, the reason why I was privileged to do I did the first cycle of the PhD back in 1983. I think now we are at the 39th, maybe even the 40th cycle. So it's like 40 years ago, basically. And in my first cycle, I had the opportunity. I had my mentor, Professor Sciarico, was one of the leaders of the robotics community at the time of Progetto Finalizzato Robotica by CNR, along with other guys like Professor Somalvico, Professor Nicosia, Professor Nicolò, and Professor Dario, of course, and many others. So, I mean, I was influenced by, really, just reading a lot of books about science fiction. and about cybernetics. And one of the most known writers of science fiction was Isaac Asimov. So, and probably you heard the famous 3 fundamental laws of robotics, which actually establish a sort of relationship between human and machine. So if we want to bring together AI with robotics, and also with the technology, with engineering, but by accounting for what were the, the statements in like the fundamental laws of robotics, like Asimov, the thing is that we have the intelligence, we have the perception, but what is the extra element of robotics? Is the action, is the physical action. And so to this regard, we cannot, if we want to rely on purely AI-inspired, AI-embedded systems, since you have a sort of physical action, you might have some safety, moral, and legal consequences, which would be unexpected. And in the AI and robotics literature, there is a famous paradox, which is known as Moravec's paradox. And you probably remember that Deep Blue was a computer which defeated the world champion of chess. Now, if we are concerned not only with data, not only with intelligence, but also with the physical action. So if we want to just relate the perceptual skills with the motor skills, we find out that the comparable performance of an intelligent machine, aka a robot, is equivalent to that of a 1-year-old child. So it's much less developed than the intelligence of which you can find in the computer that defeated the world champion of chess. So here we have a sort of big challenge. On one hand, we have the capabilities offered by the cognition of AI. On the other hand, we have the capabilities offered by manipulation. And actually, if we speak about the hands, if we speak about the manipulation, we can even develop the concept by just observing how a child grows and evolves and becomes more intelligent in the first month of their life. What do the children do? They touch. They touch, they explore the world, they touch and they grasp all kinds of objects. And usually they tend to bring those objects to the mouth, actually. And of course, the parents have to be careful, they're worried because, they can eat something. But the gesture of bringing whatever they found, the object to the mouth, it's like they bring towards themselves, toward their soul, toward their brain, just they're very kernel. So if we observe this, we can even develop this concept of dichotomy between manipulation and cognition, between body and mind, by making a sort of comparison with 2 big philosophers of the Greek time. I'm speaking about Aristotle and Anaxagoras. Aristotle was a kind of very human-centric theorist because he believed that human being a superior creature, superior being, then also developed the ability of interacting with the world just by walking, by grasping objects, so the body. Anaxagoras, on the other hand, was of the opposite theory. Anaxagoras his theory was more for the children. So Anaxagoras believed that thanks to the exploration of the world, thanks to the tactile perception, thanks to the manipulation, then a child becomes more and more intelligent and evolves and becomes a level of superior intelligence. So this is a concept which in the literature of AI and robotics is known as the embodiment. So at the end of the day, it's not only the neuronal intelligence, but it's also the peripheral intelligence concerned with the limbs, in this case with the foot, with the hands, and there's a sort of embodied intelligence also with the shape and the actions of the organs, which are the hands, ultimately for manipulation. So here we come to the concept which is now it's becoming just more and more accepted into our scientific community, and this is the concept of physical AI. So other than wearing the hat of the AI expert, because it's like typically people working at AI, they look at robotics as just one of the end applications of AI, which is fine. Now, I think I can define myself, I can tag myself as a roboticist, and if I wear the hat of a roboticist, I would look at AI as one of the enabling technologies of robotics. I think it's a sort of stupid. Sees like what is what, and it's like, you know. But the big challenge of developing intelligent machines nowadays is found at the intersection of robotics with AI. And thinking back about Moravec's paradox, physical AI is much harder than ChatGPT and than the pure AI algorithm. And furthermore, the deterministic use, the blind use of the AI in robotics can be potentially dangerous. And I will come to this concept a little bit later. So when we speak about the physical and robot interaction, so this was the iconic movie of modern times, almost a century ago, 1930, and this was the human to comply with the machine. And as you saw, the dream of realizing a fully autonomous machine is probably a loser, in the sense that the poor Charlot, not only is he frustrated by the working shift of just like feeding the machines, and is like the alienation of the metaphor of modern times, but actually the engineers want to feed him during his lunch break with the machine, and in case something goes wrong, it's the human to comply with the machine. So this, I mean, this actually, I teach Foundations of Robotics course here at University of Napoli, Federico II, but also I teach a sort of advanced robotic course, which is robot interaction control. And this is my very first class, in which I show often it's been the case that the cinematography has been a sort of precursor. And here we're speaking about a century ago, where the technology was not yet there. Robotics was not yet established as a discipline, as a field. And this was, you know, the danger of having a fully autonomous machine. So if we want to elaborate the concept of the physical human-robot interaction, we bring to a new concept, which we have introduced into our community together with a dear colleague and friend, Antonio Bicchi, who is a professor of robotics, University of Pisa, and also is a senior scientist at IEIIT, and is currently the president of the IRIM. IRIM is the National Institute of Robotics and Intelligent Machine, which gathers all stakeholders, not only researchers, but also people from industry, from startups in robotics and intelligent machines in Italy. And this is quite remarkable an effort, because actually I'm a professor of control, but for instance, it's like Christian Cipriani, who is the scientific coordinator of the Fit for Med Rob, and I understand that he gave a talk within this you know, operative program of CNR. Christian is a professor of biorobotics. So, you know, just robotics is strongly interdisciplinary. And so now we have a common home, which is IRIM. So going back to the comment that we published together with Antonio Bicchi in Italy a couple of years ago, we just show there, we just explain how we are living a sort of transient, a sort of transition from 3 decades of the development of ICT, information and communication technology, to a sort of new technology. And we introduced the acronym IIT, which stands for Interaction Technology, where the A is intentionally capitalized not only to distinguish the acronym from IT, which would be information technology, but also to stress, to emphasize the importance of the physical action and the need of developing suitable devices to allow humans to interact with machines. So this is IIT. So now you are probably familiar with the 4 revolutions of 4 industrial revolutions, you know, from the first revolution to the second revolution, third revolution, and then to the Industry 4.0, which was about 12 years ago, started in Germany, and then it was adopted at European level. And this was with the development of the so-called cyber physical systems. So with the cyber physical system, you want to bring the intelligence, the cyber, with the physical system. So it's like it's a first move towards having a robot which could interact with humans. And in fact, the icon of cyber physical system of Industry 4.0 is definitely the cobot. Cobot is a new word which has been introduced, which means a robot which is used for human-robot cooperation, aka a cobot. And I have a short video to illustrate how an industrial robot can become a cobot and can be used in a sort of intuitive fashion, like any kind of plug-and-play device, like, for instance, a smartphone or a tablet. And I'll let you watch this.
It can be a lot easier than you think. We could just show the robot what it's supposed to do. Listen, imagine this is our workpiece, and this is our robot.
Okay. It's insensitive, it's deaf, dumb, and blind.
Yes, but it moves with great precision. Now, if it's supposed to drill holes here, I just show it the positions, starting here, 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 and finishing here. The robot remembers the coordinates and repeats the procedure, and that's it.
Whoa, that thing is dangerous. It belongs behind a fence.
Not if it's equipped with an anti-collision system. Huh? And if we give it a soft reaction to touch, besides making it lighter, it wouldn't do any harm even if it did crash into something or someone.
Not bad. So you could actually work safely in the same workspace as the robot.
Right. And because the robot is now so light, you could easily move it from one location to another.
Wow. So, you could just actually carry it across to the shop floor and train it to load the machines. Ah, but wait a second. But for detecting complex parts, this isn't precise enough.
Well, to simplify the programming, the robot could be equipped with a camera or a 3D sensor, so that it could detect the exact positions of the workpieces and choose the best one to grip next.
Yes, yes, of course. And then it might even understand spoken orders.
Hey, why not? Place pump case in workpiece carrier. Hey.
So clearly the two actors that were just, playing the role of like workers on the shop floor, just they are developing the application. It's a kind of friendly, safely, and intuitively. So this is the main paradigm of Industry 4.0. But the field is evolving, and now we are moving towards Industry 5.0. And what are the difference? So the difference are emphasized here on the left of the picture of the slide in terms of the work of the labor. I mean, just as typically in a human-robot interaction, the focus was either on the human or on the machine. So the main challenge of Industry 5.0 is human with machine. Also, the cyber-physical system which was the natural development of the digitization of industry, at the system level has become a sort of AI-inspired system, a sort of cognitive cyber-physical. So again, in the paradigm of cognition, which is identifying AI. In terms of the products and services, we can move from target groups, where just like the cobots were used in Industry 4.0, towards the effect of personalization, of customization, to individually personalize products. In terms of the supply chain, it's not only the data analytics, but it's the responsiveness and the distributed flavor of the supply chain, thanks to the further advancement of technology. And last but not least, in terms of the networking, we are moving from the Internet of Things and having connected devices to a greater customer experience. And I will elaborate this concept of the Internet of Things in one of the next slides. So the three main paradigms characterizing Industry 5.0 are human-centric, promoting talents, diversity and empowerment, resilient, which is a very buzzword, especially with next generation Europe, in sense that the system to be developed, the intelligent machines, have to be agile and resilient with flexible and adaptable technologies. And last but not least, sustainability. So any action which has to be undertaken by the system must respect the paradigm of sustainability and also respect in terms of a circular economy, in terms of the green planet, what are known like respecting the planetary boundaries. So this is the move from Industry 4.0 to Industry 5.0. But technology is also offering something else, and this is the case of 5G, the fifth generation of wireless technology. Now, this is, in the 5G literature, is the so-called magic triangle. Not only do you have an extreme mobile broadband, and also have the capability of a massive machine-type communication, but the most important feature for the development of robots and intelligent machines is probably the ultra-reliable low-latency communication, and the fact that the latency can be predicted. It's not only smaller than 4G, but can be predicted. So we have a wonderful opportunity toward the development of a new generation of robots in which we can exploit the concept of the cloud. And because of having robots and humans, machines and humans, not only connected locally, but also connected globally, and also the capability of controlling robots dynamically in real time. Think about COVID. What was the lesson learned after COVID? We learned just to do smart working, and it was a sort of upgrade on the networking capabilities and continue to work. But as a matter of fact, because of the lack of mobility, and because of the safety in accessing environments, because of poor sanitation and the danger of contagion, we didn't really do the physical smart working. So that's why we should prepare for the next step, for the next development of technology in such a way that if there is another pandemic or another contingency, we can probably achieve the concept of controlling a machine, not only in terms of the communication channel, in terms of the perception, in terms of the intelligence, but also in terms of the physical action. And I'm going to show you in the next slide a movie.
Of rapid progress, when precision robotics, advancements in AI, and the capabilities of 5G can accelerate innovation, revolutionize logistics, and enhance our daily lives. When robotics, AI, and 5G work in unison, new possibilities emerge. This is the invention age. It starts with Qualcomm.
Of course, this was a commercial movie. I'm not paid by Qualcomm to show this movie, but actually I like this movie because it was very inspirational on this new concept. What is the concept? It's like using 5G and constant latency, we can probably achieve the next step of 5G enabled tactile internet. So we can fully exploit the ultra reliable and ultra responsive network connectivity for real-time control and physical tactile experience remotely through suitable haptic equipment, through devices, like interfaces. So going back to the concept, which was one of the features of Industry 4.0, Internet of Things, we are moving from Internet of Things to Internet of Skills. So it's not only the data, it's not only the intelligence, it's not only the cloud, the big data, but it's the capability of reproducing human skill, including tactile feeling over the internet. And so that's why we speak about iOS, Internet of Skills. So if we think about a very well-known concept, which is the concept of the digital twin, and we want to contextualize the digital twin into a physical environment, we are probably soon to develop a phygital twin. So to this regard, a core technology enable for the Internet of Skills is the capability of achieving haptic control not only on a one direction channel like leader follower, but just by a bidirectional channel where you can have perception and you can compensate for the latency, so you can have the apparent feeling of zero delay. And only then, from the master domain to the controller domain, you can have a real physical smart working system. So a machine or a robot which can be controlled remotely over the internet. So if we just elaborate this concept, this slide is taken from the work program of Horizon Europe. These are the four main pillars of robotics, AI, and data. Actually, I have to say that even at European level, there's been a merge among three different societies. We've been active within the Robotics Society, which is the historical European society of which the various institutions are a member. And for instance, our university, together with other Italian universities, were among the founders of Robotics. But there's been a merge with AI community and with the big data community. And now at the European level, we have ADRA. ADRA stands for AI Data Robotics Association, and the work program in the 9th framework is like Horizon Europe is organized around these four pillars. The first pillar is the factories, the traditional field of robotics and intelligent machines, which is the factory which is reimagined, just especially, and is a big boost in logistics. The second pillar is the field of non-destructive testing, with some autonomous robots, like for instance drones which not only they use as a sort of flying eye, but also as a flying hand. This is the field, for instance, of aerorobotics. And the third pillar is, of course, the healthcare and the well-being, which is completely revolutionized. You see here some sort of surgical application, but also in the rehab field has been, this technology is leading to a big advancement of field. And last but not least, robots in the field, untethered. And this one big scenario of application is the agri-tech. It's like, and especially the agri-food, which is one application of robots on the field. Say that I want to tackle another issue, which is typically a sort of like a stereotype, which actually, if I look back to the World Economic Forum in Davos about 7 years ago, there was a provocative statement that because of robotics and automation, 5 million of jobs will be lost in the following 10 years, which actually this is happening every time that we have a technology upgrade, technology step. So what are the jobs at risk? Are robots really job killers? Are we have to fear about technology unemployment? So this is a short video by Fortune Radar, which is like trying to just characterize what jobs are at danger. It's clear that some jobs which require a sort of physical action, or maybe some sort of like cognitive action at a very low level, those jobs, which probably no one wants to make anymore, are to be replaced by robots. But there are other jobs, like for instance, like truck driver or assistants in the operating room, where you need a sort of coexistence of humans with robots. So it's not just to replace, but to use this technology. It's like to as a sort of adjoint technology to the ability of the humans. So for instance, a truck driver, like lane tracking, can go to the bathroom, and then maybe when they have to exit from the autobahn, from the freeway, just like you can take the human control. So the highly repetitive and also the dangerous jobs, or maybe the alienating jobs, like going back to the metaphor of modern times, are those, like retail, warehouses, company, are those to be feared. But actually, if we look at, for instance, what happened with one of the big players, I'm speaking about Amazon. There was an article in The Guardian about a year and a half ago, just like after COVID, in which they were just counting the number of jobs, or actually of robots, which were used in the plants, in the logistic plants by Amazon. And in the observing time window, there were 500,000 robots used. And you would think that 500,000 jobs would be lost. And it was not the case, because in the same time window, 800,000 new employers were hired by Amazon. So it's a matter of turnover. So in the face of jobs lost, there are like jobs gained because of the technology. And probably we could avoid that one of the workers in the logistic plant of Amazon, probably you read about, they were even forced to make a pee in the plastic bottles, because once you press that button with Amazon Prime, like Sunday morning, just a package is delivered to your door. And if you look at all the supply chain behind us, also that includes like, just like workers doing a very sort of humiliating job. So you have to think about technology in a positive sense. And if we touch upon these issues of technology and employment and so forth, we cannot avoid about addressing what are the so-called else issues. Else is a preposition in English which has a meaning, but here is used as an acronym which stands for ethical, legal, societal, and economic issues, or not of the machines, because robots as machines do not have an ethics, but those that design, construct, and use robots. So we have to look ahead towards a sort of anthropic environment in which you have a cohabitation of humans with robots. And to this regard, we should not neglect what are the fundamental human rights and the moral duties corresponding to them, so this is one example in where robotics is going beyond the boundaries of engineering and technology. And speaking about robots and humans, I mean another author where I was really eagerly reading, whereas when I was a teenager, was Italo Calvino, which is is a journalist, is the most translated author into English language. And this, I hope that even for those not familiar with Italian can understand, just like that the imagination of a droid, the imagination of a machine is typically an anthropomorphic one. So it's not surprised that the robot manipulator has a sort of anthropomorphic aspect similar to the human arm. And if we elaborate this concept, we are into a context where on one hand, we have all the studies concerning like life, which is like life sciences, is like neurobotics, like psychologists, like biologists, and all kind of biologically inspired science together with robotics. And actually, the new frontier of robotics is biomimetics, or biomimicry, and bionics. So it's to exploit biological inspiration in design and learning from nature. And so we have to look ahead towards a future where robots are more social than solitary. So this is the concept of robot companion. So as one day we'll have a personal robot, will be like a companion to ourselves, not only like on the job, like, you know, for human work, but also for life. So robots will replace us in some sort of dirty jobs, but actually they will assist us in our homes, in our hospitals, in our factories, in our farms, and ultimately on the freeways, because like a semi-autonomous car is that all affects a robot according to the definition of robotics. So if we want to tackle this challenge, our attitude should be smart and should be one of outreach. On the left, you find by no way a non-exhaustive list of new emerging areas like biomechanics, haptics, neurosciences, machine learning, virtual prototyping, animation, surgery, sensor networks, and the list can be much, much longer. So new communities of users and developers are brought to our field, the field of robotics and AI. And as I used to say, I'm 63-year-old, and I think I've witnessed the development of the latest 40 years of robotics since the time I started my PhD. And I'm convinced that most striking advances will not be into our robotic community, but it will be at the crossroads, at the intersection of robotics with disciplines like the ones listed on the left. And so the future developments and the expected growth of the field will largely depend on our capability to achieve a true scientific cooperation with the other field. And only then, probably, robotics technology will become ubiquitous, distributed and embedded into our smart environments, like, for instance, smartphones, tablets, and so forth. So my final slide before showing a final video is a very, of course, I am a techno optimist. Probably you understood from my presentation, but I had the honor and the burden of writing the lemma of robotics for the new edition of Treccani Encyclopedia in 2020, and I just quote the prologue to the lemma, which is a famous statement by Leonardo da Vinci in Italian, and also the translation into English of the final paragraph of what I wrote in the lemma of robotics for Treccani Encyclopedia. You might know that the word robot was introduced into our modern lexicon in 1920 with a play written by Karel Čapek, who was a Czech writer who wrote this drama and brought this drama to the stage, to the theater. So that's the word robota, from subordinate, from executive work, perfectly respecting the paradigm of Asimov laws. So, you know, when I wrote this like 2 years ago, I wrote that the challenge, at the same time, the opportunity that the world of research will have to represent is related to future scenarios in which robotics will become an interactive means to help improve conditions of life. So I am in favor of a sort of what I call a technological humanism. In this vision, the robot evolution will be able to help us reassert the least artificial feature of our world, which is our humanity, our emotions, our creativity. So in the future, the robots will do part of the tasks that we do daily, and because of relieving us from this burden, I am positively and optimistically thinking that we will have more time to express our humanity. So this is a sort of renaissance of technology with the new, it's a sort of human-centric view, which in my humble view is perfect with the human-centric vision of Industry 5.0. I didn't speak about the work done by my team, but I have like one final video clip which illustrates what we've been doing at Prisma Lab at University of Napoli, Federico II. Actually, this video was done by a professional film director, Lucio Fiorentino. He works for Biennale di Venezia. He's the film director of Biennale di Venezia, and he helped me with this video. And I was asked to prepare this video when I received the Engelberger Award a year ago, around this time in Munich. So I let you watch this video, which actually titled "Keep the Gradient," which is my mantra, which is my inspirational motto, as you saw at the end of the video compilation of robots. So I start with the video.
I was born in Napoli in 1959, which was the year the first industrial robot was made. I did my studies and my whole academic career at Università of Napoli Federico II, and I always wanted to reach my goals here. Napoli is a city which naturally trains to complexity and inspires the people living in the city to develop a spirit of creativity.
I don't know, I think the audio is a sort of corrupted. Maybe let me try to show the video directly out of PowerPoint, because that's just a second. I'm still sharing the screen. I think I can easily show the video. Maybe it's because, I hope it's because of the PowerPoint. Let's see. Or maybe it's my internet connection. Yeah.
I was born in Napoli in 1959, which was the year the first industrial robot was made. I did my studies and my whole academic career at Università of Napoli Federico II, and I always wanted to reach my goals here. Napoli is a city which naturally trains to complexity and inspires the people living in the city to develop a spirit of creativity. Our Prisma Lab has been active in robotics since the mid-80s. We have grown up according to a bottom-up approach, from industrial robots to the level of interaction with the structural environment as in field and service robotics applications. Our dream and our goal at the same time has been to make robots useful and acceptable to humans. Our research work is in three main areas. We have developed bimanual robots and anthropomorphic hands for dexterous manipulation. Thanks to my ERC Advanced grant, we have expanded the team with complementary skills to work on non-prehensile dynamic manipulation and manipulation of deformable objects. We have designed sensorized grippers for handling tasks of robots in supermarkets and retail stores. Both industrial plants and civil infrastructures constitute hostile environments requiring mobile, marine and aerial robotic technologies. We have developed multicopter drones for non-destructive testing of bridges and viaducts and for aerial cooperative manipulation of payloads. We have designed a hybrid drone which can fly, roll along and inspect pipes, and an aquatic drone for eco-sustainable reuse of offshore platforms. What is the benefit of these technologies? Reduction of costs and risks. The operator can safely guide a remote robot, which then can execute tasks in a semi-autonomous way. In the field of surgical robotics, we have introduced techniques to provide the surgeon with enhanced multisensory perception, including tactile feedback, which is still missing in today's commercial systems. We have designed mini-hands and tools for laparoscopy, prostate biopsy, and suturing. At the frontier of theranostics, we are developing a new version robot with a dual-arm micromanipulator for one-stop diagnosis and treatment of precancer cells during a colonoscopy. We have introduced the instrument of small-scale experiments aimed at turning prototypes into successful products. While strengthening the cooperation between academia and industry in the various experiments, there will be an added value brought by the project. Another instrument we have introduced is that of the challenges through the exploitation of synergies across all the stakeholders to speed up the process of bringing innovative technologies from research labs to industrial end users. We are also active as digital innovation hub in the European robotics scene. Our research has also had a great impact on education. In the latest few years, at Università of Napoli Federico II, we have been observing a constant increase of numbers of master's students graduating in robotics. Thousands of students at universities around the world study robotics from our textbook. The textbook contents are also available in terms of 2 MOOC courses for web learning education. Where is robotics going? Reaching for the human frontier, robotics is vigorously engaged into the challenges of new emerging domains. New communities of users and developers with growing connections to robotics are coming together, and thus our strategic goal should be one of outreach and cooperation with these communities. The inherent interdisciplinary nature of robotics is well captured by the Spring Handbook of Robotics. The handbook received the prestigious Prose Award in the category of engineering and technology, and remarkably, it was also the winner for excellence in physical sciences and mathematics, a true consecration of robotics as a science beyond the boundaries of engineering and technology.
So this concludes my presentation, and I'm available for questions and answers. Thanks very much again.
Thank you very much, Bruno. Your presentation was astonishing and highly exciting and inspirative. Really, thank you very much. I have a couple of comments in question, but I would like first to open the floor to question from the participant. If someone is starting or waiting for this, if I got the point, no one still raise the hand. I raise my hand with a couple of consideration questions. The first one is, I'm very happy you mentioned among the mass of exciting information and ideas that you produce in my mind, and I am sure in the mind of all the participants, all the attendees. You mentioned 5G. So just I am translating with new advanced wireless communication that could change, reducing latency, you said, and I fully agree, but I think that there is something to do in this direction, because now 5G is, let me say, already an old technology. Now we are studying, also in my institute, we are studying 6G. We are studying intelligent surfaces. We are studying beyond 6G, And I think that there is many to do in this direction. But thank you very much to mention this link, particularly for the young researchers that are now attending to this evening, looking at the possibility to a real multidisciplinary of all our studies and research. Robotics, okay, robotics is the robot, is automation, is control. No, robotics is also bioengineering, robotics is also communication, wireless communication, and so forth. So thank you. I have a question, but I look that I get that Fabrizio is asking for a question. Fabrizio, after that.
No, actually, it's not really a question. I was just thinking of what you said, and I am on the same line in the sense that, okay, first of all, I enjoyed very much the presentation, Bruno, but you know that I'm a fan, so that's not. But no, the point is that this is really a message for our institute, because when you were listing all the different knowledge that can merge together, I was saying this is really one of the applications where all our institute could work together. Yes. Because our institute, when it was formed, it was sort of trying to crush together different entities, but I think that now we should. This is just my 2 cents, but now we should exploit this fact that we talk a lot of languages that are now coming together. So this exactly. Your comment at a certain point that the future is not one technology. The future is technologies together.
Cannot agree more.
So yes. We have future. That was just my comment.
Yeah. Actually, well, of course, I attend the robotics meetings because it's also a get together with old friends. I see in my windows, I see a dear friend, Vincenzo Parenti Castelli from Alma Mater Studiorum in Bologna, just like, and there are meetings like, for instance, ARK and others, like, of course, the big ICRA that we had in London like 2 weeks ago, where I like to go. But I have to confess that I get much more excited to attend the non-robotics meetings nowadays. Or, of course, at my age, in my level, I can afford that. And I send, the people in my team to the specific conferences. But I've been attending like neuroscience events, like biology, like even the National Conference of Civil Rights, and also like philosophy, just philosophy meetings. And because that's where I think that's where the inspiration will come from outside. Yeah.
No, I like. I mean, I feel the same. Sometimes we discuss with Paolo. They say, you do too many things, but that's the nice things of research, trying to put different things together. Okay, that was
a good way to think together many things together. I have a commented a question now for Bruno and for all the participants. You mentioned about the typical negative consideration about the introduction of new technologies that could kill the jobs, the existing jobs in some form.
Yeah.
And it's a very important point. My consideration in general, adding to yours, just adding, because I agree with what you said, but I could add that also this improvement in technologies, not only robotics, could in any case also generate new jobs that previously does not exist, and could generate jobs and business opportunity for industries and so forth. And probably one of our duties, let me say, Bruno, for you, for me, for all the most of the participants is to transfer our knowledge to the young people, creating new generation of experts. And linked to this comment is a question that probably you know, for particularly discussing in our project that is now running, related to robotic rehabilitation, sustainability.
Yes.
Because we are generating, for example, in bioengineering, let me say this term, biorobotics, a lot of fantastic devices. The problem could be the question if these devices could be an opportunity for all the person, for all the people, and not only limited to some case. And I think that this is a very strong, very important point to discuss if the artificial arm or hands you showed the really exciting also movies, I have to say. But I think that our challenge and our duty is also work as scientists in trying to diffuse, to make this technology sustainable. And I would like to ask you your opinion in this, on this point.
Yeah, you're very right. You know, just as like, of course, I mean, I can answer indirectly. Like make an example, because sometimes the examples are just showing how the technology can be transferred, you know, just like to become like a daily products, commercial products. Since exoskeletons, wearable robots, of course, you know this, Paolo, because, you know, we built this around, but I think for the general audience, exoskeletons were designed into labs as a prototypes, and also to be like very expensive devices, which were thought to just give back the sensory motor skills, maybe to someone hit by a stroke, or just you know, like someone in need of this technology. But now exoskeletons have become commercial devices that for all classes of population of society, and they can be worn by workers, for instance, in logistics, in supermarket, in retail stores, at very affordable technology, because an exoskeleton now is 5K. Maybe we're not yet here in terms of this technology, like a smartphone, a tablet, but soon we will be getting there. And those are used to reduce the risk of musculoskeletal diseases on the column of a worker. So it's like, and we can think about even artists, like artisans, to wear this technology. And I can make many other examples. So this is how a technology can become sustainable in terms of you know, just giving a real benefit, you know, to the society at various levels. And also, I mean, like some of our colleagues in the community are working on, for instance, on social robots, and it's been demonstrated that the empathy of a real, like Italo Calvino, like anthropomorphic, a machine with an anthropomorphic aspect, is bringing some benefits from a therapeutic viewpoint in terms of the kids suffering from like early forms of autism, or like for the elderly in treating like maybe Parkinson's, or like even Alzheimer's disease. So I mean, these are all examples how the technology, you know, just can become sustainable, and also can you know, can be beneficial for a wider and wider community of users. So this is our mission. So this is the mission. You said it right, that we have to share with the youngsters. And it's like, you know, we have. I feel that now maybe I'm speaking after, just after, just my age. I think, just as like the kernel of methodologies and basic methodologies and technologies for robotics can be considered like well assessed. So now it's the time to make all kind of, for instance, like people are asking me often about, what do you think about deep learning? What do you think about AI? Like, I say, what? I believe into the value of big data, of the cloud. If you have the data of all surgical operation made around the world in the various labs, in the various hospitals, it's certainly beneficial. But then you also have a technology which concerns with the physical world. So personally, maybe I'm biased being a control engineer, but I believe into the so-called hybrid approaches where you want to merge the model-based physics and control with the data-driven. So, I mean, for me, data is a considerable big plus to make the performance of any kind of intelligent system, model-based system, to be more efficient. So that's why we can develop a reinforcement learning. I met a dear friend and colleague, Stefano Nori. He works now. He comes from the, because he's a CNR guy, and he works now at DeepMind. Just Google in London. And we were together into a committee in Nancy in November, and he was showing me how a biped, with the deep learning algorithm, he was able to get a biped stand up and walk with a sort of controlled gait. Okay, this was really surprising. It was really astonishing. But what if just we have a model of the system, and then we enrich with data, just with the experience. So it's like, yeah, of course, just the benchmark is very appealing to show the potential of this technology, but we have to bring all the tassels together, and if we really want to develop intelligent machines which can be used, also the issue of intuitiveness is very important, and because intuitiveness also increases the confidence. We get to the wheel of an automobile, of a car, without reading the instruction manual. We have a driver's license, so we can assume that we know how to drive a car, right? And also, the technology depends on who is using the technology. Like 3 years ago, they have been working a lot on surgical robotics. I met one of the 5 top gurus of robotic surgery. He's an Italian. His name is Pier Cristoforo Giulianotti. He's a professor of surgical robotic surgery at UIC, University of Illinois in Chicago. It's one brain that has escaped, okay, and he never wanted to come back. He's naturalized American. So he shows some surgery of billiard ducts. The billiard ducts are like a thin spaghetti. It's a micrometer scale. So it's beyond, it's smaller than the millimeter scale of the Da Vinci system. Nevertheless, he was able to do billiard duct surgery with the Da Vinci system. So it's like a Formula One car. One story if Verstappen or another pilot, it's a different story if we drive it. So we have to look at this technology, at the improvement of technology, the gradient of technology, as like, getting the threshold higher and higher. And of course, the untrained surgeon, or simply the tired surgeon or the tired therapist can benefit from this technology. It's not just replacing, just as like, so I look at this as a sort of natural flow, as a stream of making this technology more intuitive and also accessible to like large classes of operators, and the users.
Thank you very much.
Serena has a question, I think.
There is another question. Serena.
Yes, just only a question related to your opinion. Which is, in your opinion, the application in bioengineering in which biorobotics can revolutionize the application itself.
I like a lot the metamorphic concept. I think it's one of the frontiers. Metamorphic comes as a sort of natural evolution of soft robotics. You know, think about the work, for instance, of Cecilia Lasky, who is now in Singapore, like the octopus is like. But it's not only the bio-inspired, but also is the capability of transforming a system. Like, and this is a trend which can be so. For instance, you know, like why we will not see like a biped humanoid? You know, although I have to say that there is a company, I don't know if you, probably you're aware because they're very aggressive on the communication. There is a company in Karate Brianza, they're called like Oversonic, and they make a humanoid for manufacturing. So they make Robbie, but Robbie has no legs, has wheels. Okay, why is wheels? But it's more advanced than an AGV type because it has independent wheels. So can just can be a bit more dexterous than a robot with kind of common wheels. So I mean, why do I say that? It's like that typically, you know, just as like you think that biped is not the, why are like manufacturers insisting, like even the Japanese manufacturers, they make humanoids, you know, just they make bipeds. Bipeds are not yet there. But I give an example. Honda invested a lot of million, like $1 billion of dollars into the Asimo project. Now, Asimo never became like a sort of commercial robot. It was a kind of platform. We use it like for show, like, you know, just like, but the fallout of that technology, the zero moment point, which is a technique for making the gate stable, controllable, was used into one of those, like they develop a unicycle. I think it's called Honda. I cannot remember the acronym. So the technique for balancing the gait of a humanoid, of a biped, is used for self-balancing of user on a unicycle. So, I mean, we really need this kind of revolutionary new platforms, because then if we think about going back to your question, to a metamorphic robot, perhaps we can create the conditions to maybe just revisit the design of some technology that up to yesterday we were designing a sort of conventional fashion. So that's why we need. I've got an advanced grant myself. You know, the pizza making robot, as it's known in the media. But I mean, the main challenge. I've also been a reviewer, and I've been 4 times a panel member for ERC Advanced, Consolidator, and Starting grants. And that's sometimes in just like it's speaking. The proposals of robotics is the most interesting and the most promising one, where just it's kind of blue sky ideas which really go beyond all the kind of paradigms which are used in conventional design. And even since you mentioned hands, like, you know, hands were mentioned, like all the new work also that we've been doing of exploiting the concept of postural synergies coming from neurosciences, and the problem and just rethink not only controlling the synergy degree of freedom, but also rethinking the design and making a hand which is mechanically designed to implement the synergies as from the single value decomposition from principal component analysis of the grass matrix. I think it's one example where, you know, where we can get inspiration. But maybe since you mentioned bioengineering, I think it's like metamorphic is very intriguing, I think.
Thank you very much. Very
You're welcome.
inspiring.
Thank you very much. Really, thank you very much, Bruno. No one other is asking for question or comment, and then we can free your evening, Bruno.